So in our final question, we are asked, what are special right triangles? So let's talk about two different types of special right triangles, okay? So two types of special seeing that line, a special right triangles. So remember, a right triangle means that one angle is 90 degrees. So this symbol I just drew here is a symbol that means angle. So right triangle means that one angle in the triangle is 90 degrees. So there's two types that we're going to talk about. We have the isosceles triangle. Isosceles triangle. Yep, okay. It's hard to spell. Which is the 45, 45, and 90 degree triangle. So let's draw that one first. Here we can look at it here. So this is what the triangle looks like. All right, so where we have the 90 degrees in this corner, we have 45 degrees and 45 degrees in the other corners, and this this side length here, oh, that was the wrong color. This side length here and this side length here should be equal. They should both be x long, and this length here, opposite from the hypotenuse, will be root 2x long, okay? So as you can see here, we have two of the same, hit that again, sorry about that. We have two of the same angles, and we have two of the same side lengths. All right. And the reason why they wrote it here without the x's for the side lengths is because you can see that if we, this was A, this was B, and this was C, we can compare the ratios of the side lengths, A to B to C, and we would see that they were 1 to 1 to root 2, okay? I think my computer is freaking out. Okay. We can read here. Side lengths create a ratio where the measurements of the hypotenuse is root 2 times the measurement of each leg. So that's the reasoning behind this. If you went through Pythagorean theorem, you would be able to find that with A and B given as x, so let's just do that quickly. We have A squared plus B squared equals C squared. And if we had this, and we wanted to find out what C squared was, we just take the square root of both sides, right? And we would be able to find that it's square root of 2x is equal to C, or back go, or that it's root 2x is equal to C. Okay, so that's how you came up with that from the ratio. And this is the ratio of side lengths. Okay, so that's the isosceles triangle. That's considered one of the special triangles. And let's look at the second type of special triangle. We have the 30, 60, and 90 degree triangle. Okay? So I explained this one previously. Let's go through it again. So what this is actually half of an equilateral triangle. Let's draw that. So if we have this 30 degrees, 90 degrees, and 60 degrees, but if we look at the full picture, the full equilateral triangle, imagine that we took this full equilateral triangle. Imagine if all these angles were 60 degrees and this full angle here was 60 degrees. If we cut that in half, we would be able to get side length where this is x, this is half of x, and this is root 3 over 2x, which can be found with the Pythagorean theorem again, which I can go through quickly. And this is half of 60 as it was 60 degrees before. The half is 30 degrees. So this is the second special triangle. Let's look at what it says here. So once again, we have the ratio of side lengths. So if we look at, start with this is C, this is B, for example, or A, or you can swap A and B. And if you take the ratio of side lengths A to B to C, you would be able to find that the ratio is root 3 over 2 to 1/2 to 1. And usually ratios would like to be with whole numbers or integers and not fractions, so we'll multiply everything by 2 to get root 3 to 1 to 2. Okay? So that's the reasoning why they don't have fractions in their example. And as I said before, the way to find A can be with Pythagorean theorem. So if we start with their equilateral triangle with all 60 degrees and all side lengths of x, then we know that C is x already because we did not touch that side, and we know that B is half of x because we cut this equilateral triangle down the middle, so the remaining side length is half of x. So we can find what A is using Pythagorean theorem again. So we have A squared plus B squared equals to C squared. Rearranging for A, well, we already know, let's just put that in, what we already know. We have B squared and we have C squared already. Let's rearrange for A, so we have A squared is equal to x squared minus x over 2 squared, and let's take the square root of both sides. A squared minus x over 2 squared. If we expand that square bracket, we have x squared on top and 4 bottom. And if we add the fractions, or sorry, subtract fractions, because we can imagine this is 4 over 4, we get 3 over 4 x squared, which gives us root 3 over 2 x squared when you apply the square, oops, just x, when you apply the square root to everything underneath it. And that will give you what the side length or the ratio is for A. So yeah, all in all, this is a ratio for the 30, 60, 90 triangle, and that is our second special triangle that we'll talk about today. Or that's, well, all of them, because the question was asking what are the special right triangles. All right, So that's everything for that question, and the solution is correct. And okay, so that's all we'll be covering today. If you did find this helpful, please leave a like, and if you want to be notified of when we do another Q&A like this, please hit the subscribe button and the notification bell. If you want to submit any of your own questions, you can see the links in the description below. And thank you.